Here it says to find the points of discontinuity and identify the type of discontinuity. That we could just graph this and then look at it and then see, or we can do some algebra and figure out what values we're not allowed to plug in. That's pretty much how we're going to find a discontinuity. So I'm thinking in this function I'm not allowed to have a 0 in the denominator, so that's exactly what I'm going to set the denominator equal to so that I can figure out the x value that makes the denominator a 0. So I'll do this and I'll solve. First I want to try and factor. This would be 3 and negative 4. What is that? Negative 3 and negative 1. This has no coefficient in front, so this is the same as x minus 3 times x minus 1, I think. So here I have a point of discontinuity. Nothing cancels out. So I have some kind of maybe a vertical asymptote, I think. But at x equals 3, I have a discontinuity, and x equals 1, I have a discontinuity, because I'm not allowed to plug these in. So I'm going to take the limit of this function as x approaches 3, and same thing as x approaches 1 from either side, and see whether it's an infinite discontinuity or a removable discontinuity. I don't think it'll be a jump discontinuity because it's not a piecewise function, but yeah, let's take a look. So if I'm looking at this limit, the top piece goes to 4, so that's nice. Maybe I'll take it from the left side. Let's see what happens, because I want to do a one-sided limit. This bottom piece goes to 3 minus 1 is 2. So I have 4 divided by 2, and this piece goes to, if I'm plugging in small values, that's x would be like 2.9999999. It's smaller than 3, so 2.99999. No negatives. This would give me like 2.999 minus 3. That would be a negative 0.0001. So that would go to 0 from the negative perspective. So that means this, well, the top staying the same. That's similar to the limit as x approaches negative infinity of this. No, not negative infinity. 0, sorry. 0 from the left side. So we're getting a negative value here, but the whole entire thing goes to infinity. So this would be negative infinity. So it does look like we're going to have an asymptote here. I don't even need to check from the right side because it'll do the same. Well, I mean, I could, if it was from the right side, this would be positive and it would go to positive infinity. You can check that by graphing. And you know what? A similar thing is going to happen if I find the limit at x equals 1, as x approaches 1. So those will be both infinite discontinuities. So find the points of discontinuity. There we go. And they are both infinite discontinuities. Just because when I take the limit as x is approaching those values, I get infinity or negative infinity. So there we go for that one.